so I'm going to try to do that today. Same problem. Remember we are discussing that we are making payment, yeah.
For the problem on Monday, did you have it in the same month that you took out, and you took out 30 grand, and you put in an unknown annuity in the same month?
That was how I presented it, but you could easily say that doesn't make any sense. But anyway, the question is not whether we are looking at the most realistic scenario. The point is, for any scenario present there, you should be able to compute future value, present value, and get the answer. So sometimes I might be making payments and taking it out, not just because it's the most realistic way to do it, but that way you'll have to think a little bit extra, right? So the way I presented it was that right from the beginning, you make payments, and you make these 167 payments, right, for 12 years, sorry, 13 years, plus 1, right? 157. And then I said that right away you start taking out, and the whole question, the problem that we are trying to figure out was how to calculate the future value, because I was calling this as 1012, right? And if you remember, the way we derived annuity was, annuity is when we're deriving formula, there was no payment at 0. Annuity started at 1. Right? So we are having some trouble trying to figure out how to directly use the formula for annuity over here. Yeah?
So can we look at 0 as like effectively a down payment?
So yeah, there are actually many ways of looking at it. So one is you could say, well, you know what, you could just move 0 here.
You're confusing us
Because
again.
the 0, sorry?
You're doing it again.
And then that's your problem if you're doing it again, because you have to understand what I'm trying to teach you. And if that confuses you, then yeah.
If you move the 0 point, then won't you add a month's worth of interest?
No, because you're not making any payment here, just as in a standard annuity calculation. So you're trying to make this look like the standard annuity so that you can use the same formula. You don't have to. You can just calculate. Another way to do it is to say, okay, I'm going to keep it 0 here. And I will not take this into account. I can definitely take the rest of those into account and calculate future value, and separately I'll add in this. Another way could be to just use the compound interest formula, create a geometric progression, just sum it up. Each will give you the same answer. And I'm happy to show you that each will give you the same answer. But you guys need to get used to the idea of looking at the same thing multiple ways. Right? It's all about understanding. You cannot just apply formulas directly. You have the habit of that, try to get out of it. Okay? So it's really up to you, but it's important to remember that the way we derive, the point is that when we derive the future value of an annuity and the principal value of an annuity, we have a formula, right? So the future value is A 1 plus I to the power n minus 1 divided by I, right? That's the formula we have derived. And the principal value is A, and then basically 1 plus I to the power n, 1 plus I. Right? These are the formulas you have derived for annuity, but it's important to remember what these formulas correspond to. These formulas correspond to a picture where this is time 0, there is no deposit made, and then of course we made n payments. Right? So number of payments is n, starting at 1, 2, 3, dot, 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 up to n. So as long as your cash flow diagram looks like this, you can directly apply these formulas, no problem. But if the cash flow diagram looks slightly different, you have to figure it out what to do. Like in this case, right? This you can see looks slightly different. But as I'm saying, you could easily actually apply this. You can apply this formula, no problem. If you realize that all it is your first payment is made here, so you can call this to be 1, 2, 3, 157, and really this is 0. And so now you can apply this, right? Because you haven't really changed anything, you have just renumbered number of months. So the future value simply will be annuity 1 plus I to the power n. Now what is n in this case? 157, it's the number of payments. Right? Minus 1 divided by. This is all fine. Okay? Yeah.
If you move over 1, wouldn't you add a month at the end? Technically?
Why would you? I don't
If you're
understand.
moving over 0.
We already did. That's why this became 157. Right? Another way to do this could be that you don't want to do it. Let's say that you say, okay, you know what? I'm just going to call it 0. Okay, I don't want to deal with this. Okay, so in that case, this is of course is 156, right? All right, so in that case, what you will do is you will say, I'm not going to consider this payment, right? So without this payment, you can apply the same formula, except what will be n? 156, right? So you say, okay, the future value is going to be a 1 plus I to the power 156 minus 1 divided by I, right? Plus what? Plus this one payment, right? A, or do we multiply that by? Because that has to be taken from here to here. 1 plus I to the power 156, right? And now you can sum it up. So you can take I common, right? If you look at this term and this term, you can take 1 plus I to the power 156 common, right? So if A here, 1 plus I to the power 156, 1 plus I. Okay, does it make sense? Right? You multiply and divide by I, so you can write this as A times I divided by I. Just add these two. 1 plus I to the power 156 comes out, you get 1 plus I. And lo and behold, that number, of course, is exactly the same as this. Right? You can also just sum it out as a geometric progression. And you will, again, get obviously the same results. Yeah.
So for the extra term, if you're moving the point at 0 all the way over to point 157, that's because there's 156 spaces in between? Is that, like, how do you
156 compounding periods. Yes.
Number,
Periods. You're moving it from 0 to 156. So how many months? And money is compounded monthly, right? 156. Yeah.
So
Yeah.
dealing with 156 months, are both i's nominal in this case? Or?
So yeah, so I cannot be I nominal. I will never be I nominal. Right? What will I be? I nominal divided by 12. Right? Very good. So I in this case is 6 divided by 1200. Or 3 divided by 1200. I don't know what rate we're using. However, now if you want to calculate the value of this at point 0, right? Then what you would do? What would you do? So you could say, so let's say that we had to calculate the principal value at this point. Now you can certainly do what I did, the future value, and then divide by what to bring it here?
12,
Huh?
56.
Very good. So multiply by 1 plus I bar minus 156. Right? Which is what you were saying. Divide by 1 plus I bar 156. That's good. But you can see this answer is correct. But if you want to think of this as an annuity, if you use directly this formula for P, you divide by 1 plus I to the power n. So you would have divided by 157, right? And that's because if you think about it, to convert this whole thing to an annuity, we have to bring 0 here, 1 here, right? That's the only way to bring this whole thing into annuity. In which case, the principal value will be the value at this point in time. Does it make sense? Yeah.
so the principal value is what money would look like if you'd made one payment and waited over that period.
Yes, the value, so the principal annuity, the principal value of an annuity is the value at time 0. Future value is the value of the annuity at time n. For the cash flow diagram, where there's no payment at 0 and then payment up to 1, 2, 3 up to n. That's just what an annuity is. if you want to use formulas for annuity, you've got to understand what the cash flow diagram looks like an annuity. And if the cash flow diagram doesn't look like this, you cannot directly use these formulas. Okay, that's the whole reason I'm having this long discussion. That you can use formulas for annuity for the future value and principal value, but only if the cash flow diagram looks like this. If the cash flow diagram looks a little bit different, you have to take into account those differences. Okay? And those differences, like I say, it could be an extra payment here. It could be slightly different. Yeah, you have a question?
You were calculating annuity with the present value or principal value. Wouldn't it, on the cash flow diagram, would it be positive instead of negative?
Sorry, this?
No, on the cash flow diagram.
No, positive and negative almost really is irrelevant. It all depends upon whether you're giving money or taking money, but you can always bring the value to the same, to beginning. Right? So you can structure, so the positive and negative depends on who, from whose perspective you're looking at. Right? So that's, in most cases, it's almost irrelevant. It depends on really how you look at the problem.
Okay.
Yes?
I think what he's saying is that since the payout steps in the diagram that was shown before have the payouts being positive values, we expect the principal value also to be positive, is what he's saying.
As I said, the principal value is the value of all this annuity. Now, usually the reason you'd be calculating the principal value is because you took a loan, right? And so the actual cash flow diagram would look like this. That's the actual cash flow diagram. But if you're trying to look at the value of that, that will still be negative. Now, that will be equal to this in most cases because that's how the cash flow diagram is structured, right? But the actual value of an annuity is obviously of the same sign as the annuity itself. Right? It's used to pay off something which is of the opposite sign. Okay, does it make sense? Okay, is that kind of clear? So remember, the important thing is that formulas have to represent the cash flow diagram. You can't just blindly use a formula for F and P, because in the past students have done that. That's how to make sure you understand that yes, you can use the F and P for an annuity to sum it up easily. But if you don't want to lose any points, you've got to understand that F and P correspond to this cash flow diagram. Any differences from this cash flow diagram, you have to take that into account. Yes, there was a question there, yeah?
So you guys have to say that if you want to calculate the principal at point 0,
Mm-hmm.
can you say how you do it again?
Okay, so in this case, so this problem, in this case, of course, it's very easy, right? The principal would be the value here. But in this case, see, where you define 0 is really entirely up to you. In the question I gave you, I said there's a payment right now, and then there are 156 more payments, right? And if I tell you find out the value of this annuity at the time the first payment is made, that could be another way of saying it, right? I could say, okay, you made n number of payments, find me the value of the annuity at the time the first payment is made. Right? That would be the value where? Here. Right? And so you have to factor that in. The principal value is always the value at time 0. Okay? Now, usually I can't think of a reason why I would ask you to calculate that. Right? Because the whole part of the annuity is that usually there is no need for the payment at time 0, because that's where you borrow the money. Okay? Sorry? What was that? Was that a machine talking to me? What did the machine say?
I didn't quite catch that.
Sorry. I'm sorry. How can I make it up to you? Okay, does that make sense?
Yes.
And again, most likely I will not give you problems where the annuities are different than the standard ones. The whole point I want to make is do not just blindly use formulas. Okay, if you do that, you're likely going to not be very successful. Yes, those questions.
If you were calculating the present value at the time of the first payment, could you use the formula and then just adjust it moving forward?
Exactly. So you could say, okay, so let's see how you do it. You say, okay, these are all formulas are correct. If I ask you, okay, what's the value of the annuity at the time the first payment is made? What's the answer? You can actually use either of these two, except move it. The principal value is the value where?
0.
At time 0. So how will you move this to time 1?
Apply double side.
Excellent. And that becomes the value P1. The value at, right? Or you could say, okay, I'm just going to use this. I'm going to bring it back from here to here. So what do you divide by? Or what do you multiply by? 1 plus I.
Negative minus 1.
N plus 1. Or negative n minus 1. Right? Exactly. You see, you get the same answers. Right? Yeah.
Can we do that from scratch?
Okay. So if you want to calculate the value of this at time 0, what will be the value of the first payment? First payment is A. What will be the value of A at time 0? Very good. So let's just write it as A over 1 plus I. Okay? So next will be A 1 plus I squared. Dot, 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 and how many payments?
156?
Well, yeah, but in this case you're writing n, right? So n payments.
Oh, yeah.
So A over 1 plus I to the power.
Then
Sorry? Well, not n fifty. Let's just say n. N because n equals to 156 is a special case. So let's just, we are only looking at this. We're trying to find out the value here. So to the power 156, right? Because between time 0 or n, I'm sorry. Right? Yeah, because we are always looking at, we're moving money from here to here. So n minus 0. If you're moving the money here, it would have been n minus 1. Right? Okay? So this is geometric progression. We always sum it the same way. We say b, right? R to the power n minus 1 over r minus 1. Where r is the ratio of two successive terms. And n is the number of terms, right? Okay? So actually it's not a good way to use n here because n is confusing. Let's just write it as, okay, what's the first term?
A over 1 plus I.
A over 1 plus I. So r is the first term. Then r. R is the ratio of any two successive terms. What is that?
1 plus I to negative 1.
Okay, so 1 plus I power negative 1. And then how many terms? How many terms are here?
and
Sorry? N plus 1 or n?
n,
Sorry?
n,
N, very good. So times n, so you get minus n, right? And then minus 1 divided by 1 plus I to power minus 1, right? Okay.
Is it that times negative 1? Same thing. Flip, right? So it'd be 1 minus.
Sorry, what? R minus 1,
Times
right?
negative
1 plus I to power negative 1, yeah, because that's what is asked.
1. No, should it be 1 minus 1 plus I to negative 1?
Well, it depends. If you depends on how you write the top. You have to be just consistent, right? If you write r to power n, it has to be r minus 1. If you write 1 minus r, you have to do that. You just have to be consistent. Okay, so this becomes a becomes 1 minus 1 plus I to power n, right? Divided by 1 minus divided by 1 plus I to power n. That's just the numerator, right? Yeah? And denominator becomes 1 plus I goes there. And this becomes 1 minus 1 minus I, so it becomes minus I. Right?
How did you get the I plus 1 plus I to the n?
I just took I just wrote as 1 over 1 plus I to the power n, so that denominator common. This just gets 1.